Okay, so this video is going to be about section 2.1 on matrix operations. This should mostly be a review for you from your algebra classes, but it's still good to go over, make sure that we can all do these things. So the idea is, previously we just talked about matrices as these things that we used to solve systems of equations where we didn't write the variables down. It's kind of a convenience sake. But now we're going to treat matrices as if they're their own thing. We're no longer going to care about systems of equations right now. We're only going to see, okay, here's a matrix, what can I do with it? And so the first thing you can do is you can do what's called scalar multiplication. And scalar multiplication is when you are multiplying a number times a matrix. So let's suppose I want to hit the number 5 and multiply it by the matrix 1, 2, 3, 4. So when you're doing this, it's exactly how you would hope it would be. All you're going to do is you're going to distribute that 5 in, multiply 5 times each part separately, and that will then give you the result of this. So when you multiply a number times a matrix, there's really no trick at all about it. They have a different size matrix here. Let's say I have 1, 2, 3, 4, 5, 6, 7, 8. And we're going to multiply it by 9, let's say. Again, we're just going to go ahead and multiply each part separately. 9 times 1, 9 times 2, 9 times 3, 4, and so on. And that's what you do. So scalar multiplication, usually not a problem for most people. That's the first operation you can do with a matrix by itself. The second thing we can do is we can do addition or subtraction. And this is also about as nice as you could hope for. So let's say I want to add the matrix 1, 2, 3, 4 with the matrix 5, 6, 7, 8. We add up the upper left-hand corners. So we're going to add up 1 plus 5 and get 6. Then we add up 2 and 6 and get 8, and so on. We get 10 and 12 here. So adding up two matrices, just add up the corresponding elements. There's no trick involved with this. Same thing with subtracting. Let's say I want to do 5, 6, 7, 8, and subtract the first one, 1, 2, 3, 4. Just subtract individual coordinates here, and you see we get the answer 4, 4, 4, 4. It's kind of a nice answer there. The only thing that you want to be aware of when you're adding and subtracting is if you have one matrix that is a 2 by 2 matrix here, right? 2 rows and 2 columns. Maybe I'll write that down here. 2 rows, 2 columns. And you wanted to add to another matrix that is a different size here. So this one is a 2 by 3 because there are 2 rows and 3 columns. The thing is we go to try to add corresponding elements and we don't have them. For example, adding the first rows together, the first matrix row has 2 elements, second matrix row has 3. How are we going to add those together? And the thing is, we just can't. We don't even try to. So this cannot be done. And what we usually would do to answer the question is we would say that it's undefined, that there's no way to make sense for an answer here. So when you're multiplying a matrix by a number, you can multiply it just straight across, just no problems there. When you're adding and subtracting matrices, you have to worry about whether they're the same size. And if they are, then you can add or subtract without any issues. Next up will be multiplication.